all, welcome to another video of Corpnce. I'm Rono Savio, and in this video we'll be discussing on space complexity. So let's dive in. So before we start with explaining space complexity, I hope everyone are familiar with time complexity. If not, you can watch the previous video which I've explained about time complexity. So now imagine that you have a bag. I'm giving you a bag, and in that bag, let's imagine it as a school bag, okay, or a college bag, you can tell. And in that bag, I'm telling you, you can stuff items whatever you want. So let's say you are trying to stuff a notebook. Sure, you can actually stuff a notebook. No issues with that. What about a laptop? Yeah, fine. That is also totally fine. But what about now I tell you stuff a refrigerator inside your bag? Good luck with that, because you know it's not gonna work. And this is exactly how space complexity also works for code. So let's say you have a code and your code is assigned to use a particular memory, and your system has the limitations of memory too. So you should make sure that your code is using a particular amount of memory very efficiently. This is what space complexity is all about, utilization of memory in your system. So if you want to give a short definition for this space complexity, you can say it tells us that how much memory your algorithm uses for your particular input that you're giving in. And that memory actually includes input storage, variables, data structures, temporary memory used during execution, function called stack memory. Just like how your time complexity will measure your speed of the algorithm, your space complexity will measure the memory usage. And just like time complexity, even space complexity is represented with our big O notation, and the first space complexity notation that we're going to see is order of 1. So it's nothing but constant. So we'll see that. So here I'm taking an example of variables to show you how order of 1, so nothing but the constant, how it works. So here if I say a equals 10, now you see that there is one variable and that variable is holding some value 10. Notice that in memory, no matter how the value is, let's say 10,000, 10,000, it doesn't matter. There is only a single variable to be assigned to the memory. So here you can see it is constant, and you are not, like, if at all the code is running and you are not incrementing those values further, it is staying constant throughout. You can see that there is just one line and it's constant throughout. And if at all you had some other lines, it's fine, but that variable what you're storing in memory is just 1. And if at all you had b equals 10, same thing, it is constant throughout. This is still an order of 1. And this is what order of 1 is exactly. So now we'll see order of n. So you can say that the input that you're giving is directly proportional to the memory usage of your particular algorithm. So how do I show that? Let's take an example here. I'm saying a equals, a is my list here, okay? I'm saying a list, but now the range of n, at a range of n. So this list should be a range of n, and this n is going to be declared by the user. So n equals int of input, enter the range. Fine. Now here you can see that your list range is not constant, because it is going to be given by the user, and it can increase as the user increases the input range, I mean the list range. It can decrease depending on the user how is giving the range. So if at all I say print a, and now if I run this code, you see I'm already running it and it's asking me enter the range. So I'm saying 5. It's going from 0 to 4. Okay, I'll make it more simple. I'll say 1 comma n plus 1. So it's going to go from to 5. Yeah, now if I run it, I'll say 5. I'm getting 1 to 5 values, the range. But here you can notice that your input is directly proportional to the memory usage of your particular algorithm. So how much number of inputs, that much number of memory used. So if at all it's 5 memories is used, 5 memory storage is used, and if at all it's 100 memory utilized. So this is just an example like how your order of n works. So it is directly dependent on that n. So your memory usage increases as the n keeps on increasing. So that is what I told, it is directly proportional. So here we are going to see order of n squared. So what do I mean by order of n squared? Basically you saw order of n where n was directly linear, like directly proportional to the memory usage. If at all n was 10, your memory usage also was 10. But now it is n squared. So if your n, like the number of inputs that you're giving is 10, then the memory utilized is square of the particular n. So it's n squared, so 10 cross 10, it will be 100. If at all n is 100, then the square of that, your memory usage will be 10,000. So it goes like that. So I'll give an example of, let's say, matrix. We are creating a matrix. So here if I say n equals range of, no, not range actually, so I'll say input, enter the range. Okay, let's say enter the range, fine. Same, it is similar to how we had that order of n, and if at all I say for I in range n, now you see for j in range n. So you literally taking square of 2 n's now here. There are 2 n's, 2 ranges. So if I say I want my what do you say, list to be a matrix here. So if I'm creating a matrix, so A is my list that I've created. So A dot append I comma j. Now if I print A, I think I can print A outside, it's totally fine. And if I run this, if I say just, I'll say 10. Oh, my bad. I think extend would be good, or maybe I'll keep it as this. Yeah. So I'll say just 10. Look at this. There are 100 values that have been appended into your list. If you want to take the count, I'll say print length of A. So I'll say 10, 100. I told you your, what you say, code, like your algorithm, whenever you have a particular range or let's say value input from the user, and if at all it is order of n square, then you are doing 100 times. Your memory is utilized 100 times if it is 10. If it is 100, it is utilized 10,000 times. So it is in a square of those particular n range. That's what it is. So this is nothing but the order of n squared. So if at all, what if I give 100? 10,000, as I said. So yeah, this was an example for order of n squared. So that's all for this video, and I hope it gave you a clear understanding of how space complexity works. And if at all it did help you, do subscribe and stay tuned for the next videos. Thank you.